Hello, everyone. My name is Vincent, and today we are going to be looking at problem 16 from the sprint round of test 12520. So the problem states, an alien spaceship has landed in Carl's hometown, and he must escape to the train station, which is located at the top right corner of the town. However, Carl is currently at the bottom left corner of the town, so he needs to travel 5 blocks up and 6 blocks to the right. He can only travel in whole block steps, up or to the right, and he cannot go through the alien spaceship, which is 3 blocks up and 3 blocks to the right of his current location. How many different paths can Carl take from his current location to the train station? So first notice that something the problem tells us is that Carl must travel 5 blocks up and 6 blocks to the right. What we can represent this as is Carl must take 5 movements that are up and 6 to the right. But the order in which he takes these steps to get to the train station, this doesn't really matter, right? You can go 5 up, 2, 3, 4, 5, and then 6 to the right, and that would be fine. Or he can go 2 to the right, 1 up, 2 to the right, 2 up, 2 to the right again, and then 2 up again, and he would get to the same place. And this would be another valid walk or path to the train station. What we can think this of is if we have 5 up and 6 rights, arranging these 11 movements in any order without repeat. And how we can do that is we have 11 spots and we choose 5 of them to be ups, right? And this would be equal to 11 factorial divided by 5 factorial times 6 factorial. And what happens is we can calculate this to be 11 times 10 times 9 times 8 times 7, all divided by 5 times 4 times 3 times 2, and canceling. We see that 8 cancels with 4 and 2, 5 cancels with 10 to get 2, 3 cancels with 9 to get 3. So essentially we have 11 times 2 times 3 times 7, which we can calculate. My suggestion is to calculate these 3 first. It would become 46 times 11, or 42, sorry, times 11, which is equal to 462. So these 462 paths are simply the paths it takes to get from where Carl is to the train station. But notice how during this process, we've completely ignored the alien spaceship right here. So now what we can do is we can take the total number of paths that Carl can take from where he's beginning to the train station and subtract the ones that goes through the alien spaceship where it is blocked. So how can we find how many ways there are to go through the alien spaceship? Well, Carl always has to start at this point right here, and he always has to end right here. And if he always has to pass through this place, then he must always go 1, 2, 3 to the right, and then 1, 2, 3 up in some combination. And then he goes in some other combination, 1, 2, 3 to the right, and then two ways up, right? So we can think of this as splitting our original case into 2 different sections, right? The first section we have up 3 times, and then right 3 times. And now we can permutate this selection of 6 movements to get total number of paths Carl can take to get to the spaceship. On the other hand, for the second part of this path, he can go up twice and right 3 times. And this gives us the number of paths for the second half. And to get the total number of paths that he can take to go through the spaceship, we just multiply these 2 paths and we get our total probability. So remember what we had here, right? The number of ways to permute 3 ups and 3 rights would just be the total number of movements, which is 6. And we choose 3 to be up or right without loss of generality. And we multiply this by 5 total movements for the second part, and we choose 2 ups. And this we can calculate to be 6 times 5 times 4 divided by 3 times 2 times 5 times 4 times 3 divided by 3 times 2. And now we know 3 times 2 cancels with 6, 3 cancels with 3, and 2 cancels with 4, and get 2 as a result. And this becomes 5 times 4 times 5 times 2, which we can easily calculate to be 200. Now we have 200 cases where Carl passes through the alien and 462 total cases. To get the number of paths that he can take where he doesn't go through the alien, we can simply take 462 and subtract 200, which gives us our answer of 262. So this is our answer right here, 262. That means our answer is B. Thank you very much.
This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.